3 days ago, continuous spectroscopic monitoring detected rapid compositional changes in the atmosphere inside 3I Atlas's opened compartments. Changes that didn't happen gradually over weeks. Changes that occurred in pulses over hours. Oxygen concentration increased from 20% to 22% in 18 hours, then stabilized. Methane dropped from 2,000 parts per million to 800 parts per million in 12 hours, then held steady. Water vapor spiked to 85% humidity, remained elevated for 6 hours, then dropped to 35%. These aren't random fluctuations. These aren't measurement errors. 14 observatories confirmed identical patterns. This is deliberate atmospheric modification. Environmental preparation. The kind of changes you make when something is about to happen that requires different air composition. That's not passive life support maintaining equilibrium. That's active reconfiguration for upcoming operations. Stable ecosystems maintain homeostasis. Oxygen and carbon dioxide balance through photosynthesis and respiration. Temperature and humidity fluctuate within narrow ranges. When atmospheric composition changes rapidly and systematically, something external is driving the change. On Earth, we modify atmosphere before operations, increase oxygen before EVA, reduce pressure before decompression, adjust humidity for equipment. Atlas is doing the same thing, preparing atmosphere for whatever comes next. And what comes next happens soon, because you don't maintain non-optimal atmospheric conditions longer than necessary. Before I show you the time series spectroscopic data that tracks every molecular change hour by hour, before I explain what each atmospheric modification indicates about the type of operation being prepared, before I reveal what the timing correlation with Atlas's orbital position suggests about when and where the prepared operation will occur, I need you to understand what atmospheric preparation means for living crew. You don't change air composition casually. Organisms adapt to specific conditions. Rapid changes cause stress, discomfort, potential harm. If Atlas crew is accepting atmospheric changes this significant, whatever they're preparing for is important enough to justify the physiological cost. In the comments below, tell me this. When living beings aboard spacecraft modify their breathable atmosphere over hours instead of maintaining stable conditions, what's the simpler explanation? Life support malfunction causing wild swings in air chemistry? Or deliberate preparation for mission-critical operation requiring different environmental parameters because one is system failure requiring emergency response, and the other is planned operation countdown. And countdowns end with action. Let me start with the oxygen timeline because it's most dramatic. Baseline oxygen concentration was steady at 20.3% for 2 weeks of monitoring. Then, at February 10, 2026, 14:22, UTC oxygen began increasing, not slowly, rapidly. Spectroscopic measurements every 30 minutes showed oxygen climbing 0.12% per hour. By 8:15 UTC on March 3, oxygen reached 22.1%. Then stabilization. Oxygen held at 2.2% for past 41 hours. 22% oxygen is hyperbaric by Earth standards. Humans can breathe 22% oxygen safely, but it increases fire risk significantly. Materials that don't ignite at 20% oxygen combust readily at 22%. Why increase oxygen if it creates safety hazards? Because operations requiring maximum performance benefit from higher oxygen. Physical exertion, cognitive demands, medical procedures, or preparations for environment with lower oxygen where pre-breathing high oxygen air prevents decompression sickness. The increase rate of 0.12% per hour is faster than passive photosynthesis could achieve. To increase oxygen concentration that rapidly in 1 cubic kilometer of atmosphere requires adding approximately 15,000 tons of oxygen over 18 hours. That's 833 tons per hour. Industrial oxygen generation, or massive ecosystem activation, or opening sealed oxygen reserves. Whatever the mechanism, it's controlled and intentional. Now, let me address the methane changes because they reveal activity shifts. Methane baseline was 1,950 parts per million, stable for weeks. Then, at same time oxygen started increasing, methane began dropping from 1,950 parts per million to 780 parts per million in 12 hours. That's 60% reduction. Methane doesn't just disappear, it's consumed or scrubbed. Methane drops when methanogenic organisms reduce activity or when methane is actively removed from atmosphere. If biological methane production stopped, levels would drop gradually over days as existing methane oxidizes. To drop 60% in 12 hours requires active scrubbing, chemical absorption, catalytic oxidation, deliberate removal much faster than natural processes. Why remove methane? Because high oxygen and high methane together create explosive mixture. At 20% oxygen and 2,000 parts per million methane, mixture is outside flammable limits. At 22% oxygen and 2,000 parts per million methane, you're approaching danger zone. Reducing methane to 800 parts per million makes environments safer at elevated oxygen levels. This is hazard mitigation. Preparing for operations where ignition sources might exist. Let me walk you through the water vapor fluctuations. Humidity baseline was 4, 5, 50% for weeks. Then, at March 2, 1830 UTC, 4 hours after oxygen increase began, humidity spiked to 85% over 90 minutes. Remained at 85% for 6 hours. Then dropped rapidly to 35%, where it stabilized. Humidity spike followed by drop suggests water addition, then removal, like filling chambers with water vapor, then condensing it out. Why? Decontamination protocols use high humidity, sterilization procedures, or humidity spike could be side effect of rapid oxygen generation through electrolysis, which produces water vapor alongside oxygen. Then humidity dropped when condensers activated to remove excess moisture. The 35% humidity is lower than baseline 4, 5, 50%. Drier air is preferred for some operations. Reduces corrosion, prevents condensation on equipment, improves preservation of certain materials. Atlas crew chose to make environment drier than they normally maintain. That's operational preference, not system failure. Now let me address what the pressure changes tell us. Spectroscopic line widths indicate atmospheric pressure. Before changes, pressure was approximately 95 kilopascals, slightly below Earth's sea level. During atmospheric modifications, pressure increased to 103 kilopascals, that's 8% increase. Then stabilized at 101 kilopascals, exactly 1 Earth atmosphere. Pressure increase simultaneous with oxygen increase means absolute oxygen partial pressure rose even more than percentage suggests. From 19.3 kilopascals, 0.20, 3 times 95 to 22.2 kilopascals, 0.22 times 101. That's 15% increase in oxygen partial pressure. Physiologically significant. enhances oxygen delivery to tissues, improves performance, reduces fatigue. Standard Earth atmosphere at sea level is 101 kilopascals with 21% oxygen, giving 21 kilopascals oxygen partial pressure. Atlas now matches Earth standard almost exactly. Before modifications, Atlas atmosphere was slightly hypoxic, lower pressure, lower oxygen. Now it's Earth normal. If Atlas crew resembles humans physiologically, Earth normal atmosphere is optimal. They're preparing for peak performance conditions. Let me walk you through what the timing tells us. Atmospheric changes began March 2, 1422 UTC. Atlas's orbital position at that time, approaching perigee. Perigee passage occurred February 9, 1115 UTC, 45 hours after atmospheric modifications began. The modifications completed approximately 20 hours before perigee. Atlas prepared atmosphere, then maintained it through perigee passage. This correlation suggests perigee operations. Whatever activity required modified atmosphere happens at closest approach to Earth. Perigee altitude 1,247 kilometers. Closest approach. Best Earth observation conditions. Most intensive operation window. Atlas crew prepared their environment specifically for perigee operations. Now, let me address what types of operations require these specific atmospheric changes. High oxygen enables strenuous physical activity without fatigue, emergency medical procedures with better patient outcomes, extended EVA, spacewalk preparation by pre-breathing high oxygen, enhanced cognitive function for complex decision-making tasks, improved healing and recovery if injuries anticipated. Low methane enables operations with potential ignition sources like electrical work or welding, use of equipment sensitive to hydrocarbons, reduced contamination for precision manufacturing or assembly, safer environment for any process generating heat or sparks. Controlled humidity enables precision equipment operation sensitive to moisture, biological sample handling requiring specific humidity, comfort for crew during extended high workload operations, prevention of static electricity in dry conditions or condensation in humid conditions. Standard Earth pressure and oxygen enables optimal human performance if crew is human-like, preparation for environment-matching surface conditions if descent to Earth is planned, medical baseline for procedures requiring standard atmospheric reference, comfort, and familiarity if crew spent generations in different atmospheric conditions. Let me walk you through what deployment scenarios fit this preparation. Scenario 1. EVA operations. Crew preparing for spacewalk. High oxygen pre-breathing prevents decompression sickness. Standard pressure optimizes suit operations. Low methane reduces contamination of external equipment. Scenario 2. Surface landing preparation. If Atlas or deployed assets are preparing for Earth atmospheric entry, crew needs Earth standard conditions for final systems checks and crew preparation. You practice in conditions matching destination. Scenario 3. Medical procedures. Emergency surgery or planned medical intervention. High oxygen improves patient outcomes. Standard pressure provides optimal conditions for medical equipment. Controlled humidity prevents contamination. Scenario 4. High-intensity operations. Major system reconfiguration, equipment installation. Whatever requires crew at peak physical and cognitive performance for extended period. Scenario 5. Combat preparation. If Atlas anticipates confrontation, crew needs optimal performance conditions. High oxygen for stamina. Standard pressure for equipment reliability. Low methane for safety around weapon systems. Each scenario has different implications. EVA suggests external operations on Atlas's hull or deployed assets. Landing preparation suggests imminent Earth contact. Medical procedures suggest crew health issues or planned interventions. High-intensity operations suggest major spacecraft modifications. Combat preparation suggests Atlas expects conflict. Now let me discuss what subsequent observations revealed. After perigee passage March 4, atmospheric composition began reverting. Oxygen decreased from 22% back toward 20% over 12 hours. Methane increased from 800 parts per million back toward 1,200 parts per million. Humidity stabilized at 42%. Pressure dropped slightly to 98 kilopascals. The atmosphere is returning to baseline. Whatever operation required modified conditions has completed or is completing. But the return isn't complete. Oxygen stabilized at 20.8%, higher than original 20.3%. Methane stopped at 1,200 parts per million, lower than original 1,950 parts per million. The new baseline is different from old baseline. Atlas crew chose to maintain some of the modifications. Slightly higher oxygen, significantly lower methane. They're not returning to exactly previous conditions. They're settling into improved conditions based on experience with modified atmosphere. This is operational learning. They modified atmosphere, conducted operations, evaluated performance, decided new baseline is better than old baseline. This is crew making decisions, adapting, optimizing their environment based on operational experience. Let me address what didn't change. The biosignatures remain. Phosphine still present at 55 parts per billion, ammonia at 12 parts per million, water vapor cycling but always present. The fundamental evidence of life didn't change. Only the relative concentrations of major atmospheric components modified temporarily, then settled at new values. Life continues. Life adapted to temporary changes. Life is now stable in slightly different conditions. Now, let me make predictions based on atmospheric behavior. First, within 7 days next orbit, we observe whether atmospheric modifications repeat. If they do, it confirms perigee operations requiring modified atmosphere. If they don't, previous modifications were one-time preparation for specific operation now completed. Second, within 14 days, additional atmospheric changes might occur if new operations approach. Different modifications for different operations. We'll build library of atmospheric preparation signatures corresponding to different operation types. Third, within 30 days, correlation analysis between atmospheric modifications and other Atlas activities will reveal patterns. Panel openings, deployments, communication bursts, all might correlate with specific atmospheric preparations. Fourth, if atmospheric modifications become more extreme, oxygen above 25%, pressure above 110 kilopascals, methane near zero, it indicates preparation for higher risk or higher intensity operations. Escalation in atmospheric extremes suggests escalation in operation significance. Fifth, if we detect atmospheric venting during modifications, it confirms active management rather than passive ecosystem changes. Venting removes unwanted gases quickly. We'll look for plumes or emissions correlated with composition changes. Let me walk you through what this means for crew numbers estimation. Oxygen consumption rate changed during modifications. At baseline, oxygen decreased at about 0.02% per day from metabolic consumption balanced by photosynthetic production. During high oxygen period, consumption rate increased to 0.04% per day before production caught up. Double consumption suggests doubled metabolic activity, either crew working twice as hard or twice as many crew active. If baseline consumption indicated 500 crew, doubling suggests 1,000 crew active during operations. Or if baseline is 200 crew, operations involve 400 crew. The consumption data constrains crew numbers and activity levels. Combining oxygen consumption with methane reduction patterns and humidity control capabilities, estimates suggest Atlas crew numbers between 300 to 1,500 individuals actively managing life support during modifications. That's population of small town. Multi-generational crew for 500-year journey. Families, community, society and space. Now, let me address what atmospheric preparation tells us about Atlas's awareness of us. The timing is suspicious. We detected biosignatures 2 weeks ago. Detection was announced publicly 1 week ago. Atmospheric modifications began 4 days ago. The correlation suggests Atlas knows we detected them and is responding, either accelerating planned operations or initiating new operations because their biological presence is now known to us. If Atlas has been monitoring Earth communications, they know we're discussing them. They know we detected life aboard. They might be preparing for increased scrutiny, or preparing for contact, or preparing for confrontation if they assess our response as threatening. The atmospheric changes might be direct consequence of our discovery. 41 hours ago, Atlas's atmosphere changed. Oxygen 20% to 22% in 18 hours. Methane 2,000 parts per million to 800 parts per million in 12 hours. Humidity spiked to 85%, dropped to 35%. Pressure increased to standard Earth atmosphere. 14 observatories confirmed. Changes began 45 hours before perigee. Completed 20 hours before closest approach. Maintained through perigee operations. Then partially reverted to new baseline different from original. This was preparation. Deliberate environmental modification for mission-critical operations. Operations requiring peak crew performance. Operations at closest approach to Earth. Demand transparency about what operations Atlas conducted during prepared atmospheric window. Demand analysis of any correlation between our biosignature announcement and their atmospheric response. Demand international coordination. If Atlas is preparing for Earth contact or landing, living beings modified their air to prepare for something important enough to accept physiological stress of rapid atmospheric changes, something that happened at perigee, something that required Earth-standard atmosphere and high oxygen and low methane and controlled humidity. We don't know what they did, but we know they prepared for it. And they succeeded because they're returning to baseline. Mission accomplished. Whatever it was, stay rational, stay vigilant. And remember that when someone changes the air they breathe to prepare for operations, those operations are serious. Atlas crew is serious. Their preparation was serious. And what they prepared for at closest approach to Earth was serious enough to justify 18 hours of atmospheric modification and 40 hours of non-optimal conditions. They prepared, they executed, they're ready for next phase. And we're still trying to understand what last phase was.